Hey guys, Mr. Inyard here. This is morning work for week 28, Monday. And it was 2 pages because the first 8 questions were on the first page. I need to scroll a little bit farther to get to question 9 and 10. But so a couple new things on here, and there'll be some side videos to go along with it. So let's get to it. All right, y'all, here we go with week 28, Monday, and we have ourselves some data questions, okay? So let's go over what minimum is. Minimum would be the lowest number, right? The smallest number in our data. So our data goes from 2, and then it could have all kinds of numbers, up to our maximum, which is our highest number, or greatest number, which is 10. So our range, right, if all we wanted was range, we could do 10 minus 2, and our range would be 8. Remember that? Range is from the biggest minus the smallest, from the smallest to the biggest at distance. All right, well, then we have these things called quartiles, and I will show you on another video that breaks down the quartiles. It'll be specifically about box plots and interquartile range, quartiles, and mean absolute deviation. So that data video will be coming and be looking on it on Edpuzzle. But for right now, let's just assume that these 3 quartiles, these are just, we're just going to call these 3 boxes, right? Box 1, box 2, box 3. This is a group of data. So group 1 of the data is here in order from least to greatest, right? The second group or box would be here, and then the third box would be here, okay? And then our max and our min. So to find the interquartile range, all right, range is greatest minus minimum, right? But we're going to focus only within, hence the term interquartile range. So we're going to stay within that red box. All right, so what is the greatest number in our quartiles? 7, right? 7 is the greatest number of our quartiles, and we're going to subtract the smallest number, 4, because what we're trying to figure out is what is the range or the distance between the smallest quartile and the biggest quartile. And to do that, you just subtract them, and you will get the answer of 3. So the IQR, or interquartile range, is 3. Okay, so let's speed that up and do it here on this one. Again, we don't really care. Obviously, minimum is nice to know, and so is max, but did that matter in finding the interquartile range? No. Remember, interquartile is within the quartiles. So we're just looking at this section from quartile 1 to quartile 3. How far is it from here to here? What's that distance between 5 and 13? So we would just do 13 minus 5, right? And what are we going to get? 8. Our interquartile range is 8. So for this, we're just looking at the median. We need to find the middle, and to find the middle, you need to order your numbers from least to greatest. So let's go ahead and take these 1, 2, 3, 4, 5, 6 numbers and order them from least to greatest. And it looks like they were already in least to greatest order once we looked at it, but I went ahead and wrote them in a line because I like to do that anyway. Now, since there are 6 numbers here, that's an even number of data. What you're going to find is as you cross them out, you're going to get to 2 numbers that are right in the middle. And what we're trying to do is figure out this, what's between those 2 numbers. So remember, in order to find the median of 2 numbers, you have to find the mean of those 2 numbers. And that's only when you have the 2 in the middle. That doesn't have, if it's an odd number of data, we would have just 1 number right in the middle, but in this case we have 2 numbers right in the middle. And since we have to go between that, we're going to add 3.71 and 2.15, and then we're going to divide by 2. So here I added them together, and I got 5 and 86 hundredths, or 5.86. And then I'm just going to do the 5.86, which is the combined sum of these 2, and divide it by 2 to find right in the center, which would be this line right here. And when you do that, you end up with 2 and 93 hundredths, or 2.93, and that would be your median. For these, I'm going to make the decision to just go ahead and make them improper by multiplying the denominator and the whole number, and then adding the numerator and writing that over the denominator. And then I am going to do keep, change, flip, because multiplying by the reciprocal here in my mind is going to be easier than multiplying both of these to get to 40. Now I could do that, but that's too many numbers. So what I end up with is this problem, because this number right here is going to be 6/5, and multiplying by the reciprocal means to flip the numerator and the denominator, and then you're changing division to multiplication. So this would be this problem, instead of division, multiplying by the reciprocal of that. And now I just multiply straight across, which is going to be 45 over 48. And I'm looking at these numbers. 4 and 8 equals 12. 4 and 5 equals 9, which means these are divisible by 3. So I'm going to at least try dividing them by 3 and see what happens from there. And when I do that, I end up with 15/16, and that is simplest form. Remember, we always want simplest form. All right, so we need to make a dot plot, which if you remember, a dot plot's like a line plot, or where you make a number line and you go from your smallest to biggest, or you can leave a little space, but I didn't want to go to 105, so I just went from 70 to 100. And then I evenly distributed my numbers, and I went by fives because I'm looking at my data, and the minimum is 70, the maximum is 100, and then they either end in a 0 or 5. So I just evenly distributed it up. And now I'm just going to put dots above each number on my number line according to what the data says. So you can follow me as I do that and see what I'm talking about. So let's see. We have a 100 dot cross, a 90 dot. And I want to make them in a straight line as best as possible. Like that was kind of bad, but again, I'm using my finger because I can't find my stylus. Because you want them to be in equal rows so that you can quickly see which one has the most, which one has the least. That way you can find your mode, etc., etc. So evenly spacing them, making them look nice straight across, that's very helpful. I'm trying to do my best with that. But again, like I said, I'm using my finger and a 95 to wrap it up. And so you can see 95 had the most, which makes it our mode. And it looks like our data is pretty skewed to the right here. Because if I were to draw, looks like it, kind of tapers off down here and we have this outlier, but the bulk of my data is far to the right. All right, here we go with some geometry, okay, finding the area, right? And this is the area of a square, since it says it's a square, but we also see that they have equal sides and we have the right angles. So to find area, we're literally what we're doing is we're making 3 units. Do you see my 3 units? I know they're not perfectly even, but 1, 2, 3, by 3 units. In this case, the units are feet. And the question is, how many little squares does that make? Each of those being 1 foot by 1 foot, that makes 9. And so we know that we're going to call those feet squared because they're literally square feet. Do you see that? This is 1 foot by 1 foot. All right, and it made 9 of them. And what we know is we can just multiply length times width. That's the formula. All right, so area equals length times width. And that works for rectangles and squares. So on this one, let's just multiply 3 times 9, right? Creates an array, and that's going to be 27. And then we know they're going to be little square yards. So we call it yards squared. You can use little 2. You could write square yards. You could spell that out. But we're squaring the units. We're not squaring 27 because 27 squared is a huge number. We did 9 times 3, and then it's yards times yards. So that's 2 yards. So we can say that's exponent of yards because it's yards times yards. And so we call that yards squared. So in our ratio table, we're looking for a rule or relationship between our input and our output. And so if I had 64, how do I get to 8? That's divided by 8. To check it, it should be the opposite rule going back, which should be times 8. And I did 7 times 8, and you get 56. So now I know my rule is that. 96 divided by 8 is going to be 12. And 4 times 8 is going to be 32. And 16 divided by 8 is going to be 2. Question 9 was on the next page. You just had to scroll down a little bit, but we're going to be focusing on this word called a proportion. Now, proportion. A proportion is just either a conversion unit or a rate. You could call it a ratio, but you're looking for the equivalence in what 30 inches would be in feet. And so what we do know is that there are 12 inches in 1 foot, right? So aren't we just going to do 30 divided by 12? And that'll tell us how many feet, right? And so 2 12s is 24, so I know it's 2 feet. But then I'm also going to have another, so that's 24 plus 6 gives me 30, so it's 2 feet 6 inches. And so the proportion that we used is 1 to 12, or 12 to 1. It's like a ratio or a conversion unit or rate that we can use. And so we just divide inches by 12, and we get over to feet. So this is when everything in the PDF document that you've probably copied over into Notability gets kind of, we'll say, weird. And there are typos, all kinds of things that the code of the computer didn't jive with when it was written. And so there's supposed to be a coordinate plane over here. Instead, there is, I don't know, an alpha symbol. But we can still plot -1, 3 as point A on this and just make it ourselves because we're creative. So what was it? -1, 3 is going to be left 1, right? Up 3. So about there, and I'm just going to call it A. And that's it. Well, there it was. Hope it was helpful. If you have any questions, let me know on Schoology, and I'll talk to you later.